Hello students, welcome to the e-learning platform of FMS. Today we are going to start with the first chapter of chemistry, that is some basic concepts of chemistry. So let us begin with the most important concept of chemistry, mole concept. In today's session we are going to discuss what is mole concept, some tips and tricks about this as well as formulas and numericals based upon mole concept. So let's start our discussion with a simplified definition of these three terms, that is atomic mass, molecular mass and molar mass. Now what is atomic mass? Atomic mass is the mass of one atom, that is single atom. Coming to molecular masses, it is the mass of one single molecule. The last term, that is molar mass, is the mass of one mole of particles, that is mass of 6.022 into 10 raised to power 23 particles. And this is how we can differentiate between these three, that atomic mass is mass of one atom, while molar mass is a mass of 6.022 into 10 raised to power 23 particles. Now these particles could be atoms as well as molecules. So if we are talking about the mass of 6.022 into 10 raised to power 23 atoms, then the mass is said as gram atomic mass. While if we are talking about 6.022 into 10 raised to power 23 molecules, then it is said as gram molecular mass. So we can classify molar mass as gram atomic mass, which is abbreviated as GM, and another one is gram molecular mass, which is abbreviated as GMM. Now let's consider an example of nitrogen. You might have seen that we write down sometimes atomic mass of nitrogen as 14U or 14 grams. Now let us differentiate what is 14U and 14 grams. So when you are writing 14U, then we are talking about mass of one nitrogen atom. And when you are writing 14 grams, that means we are talking about gram atomic mass, or you can say mass of 6.022 into 10 raised to power 23 atoms of nitrogen. Now let us learn how to calculate molecular mass. We'll try to calculate molar mass of water, calcium hydroxide and sodium sulfate. If you can calculate these, then you will definitely be able to calculate molecular mass of any compound. Let's start with water. To calculate the molecular mass of water, first we need to know the atomic mass of each atom present in this water molecule. Here there is hydrogen whose atomic mass is 1 and oxygen whose atomic mass is 16. So the total molecular mass of water will be 18, and since we are talking about molecular mass, it will be written as 18U. Now let's see about calcium hydroxide. Here the atomic weight of calcium is 40. Please remember, when you talk about hydroxide here, twice is for both OH, that is hydroxide ion. We'll multiply 2 into 16 plus 1, and that sums up to be 17. And since again we are talking about molecular mass, it will be 17U. Similarly, we can calculate the molecular mass of sodium sulfate dot 10H2O. Here this dot 10H2 is actually water of crystallization, and that 10 is to be multiplied with the whole water molecule. In case of water, mass could be written as 18U or 18 grams, where 18U means it is molecular mass. When it is 18 grams, it means gram molecular mass. Now let us see the difference between 1 mole, molar mass and atomic mass. What is 1 mole? 1 mole is actually equal to 6.022 into 10 raised to power 23. And if we are talking about atoms, it will be 6.022 into 10 raised to power 23 atoms, that is equals to gram atomic mass. In case of molecules, when we say 1 mole, it is equals to 6.022 into 10 raised to power 23 molecules, and which is equals to gram molecular mass. If there is a gas, 1 mole equals to 6.022 into 10 raised to power 23 particles of gases, and its volume is always equals to 22.4 liter, or you can say molar volume. I think every one of us knows that by changing pressure and temperature, volume of gases can be changed. So these calculations are done only at STP condition, that is standard temperature and pressure conditions, where standard pressure is 1 atmosphere and standard temperature is 273 Kelvin. No matter what gas we are talking, 1 mole of any gas is equals to 22.4 liters at STP. So here we have 4 formulas that will help us to solve any kind of questions based upon mole concept. Let us see all these formulas one by one. Let's see formulas for atomic substances. Here number of moles is equals to given mass upon gram atomic mass. You can also write down as N equals to m small m divided by gm, that is gram atomic mass. We can also find out number of moles of a molecule, that is equals to given mass upon gram molecular mass, and in short you can again write down m upon gmm. For gaseous substances, number of moles is equals to volume at STP in liters divided by 22.4 liter. In short, N is equals to V upon 22.4 liters. Here it is important to understand that volume should be in liters. And in case of particles, we can use this formula as number of moles is equals to number of particles divided by Avogadro number. And what is Avogadro number? That is 6.022 into 10 raised to power 23. And in short, we can write down N upon Na, where Na represents Avogadro number. Let's use these formulas to solve some of the numericals based upon mole concept. So here is our first question to calculate number of moles in 392 grams of H2SO4. Since we are dealing with a molecule here, N is equals to m upon gram molecular mass. The given mass is 392 grams, and the gram molecular mass of H2SO4 can be calculated by using its formula, which comes to be 98 grams. And then we can just substitute the values N equals to m upon gmm and calculate our answer. Let's see another question. Calculate the number of moles in 48.8 liters of CO2 at STP. So here we are talking about volume. So N is equals to V, that is volume at STP divided by 22.4 liter. Now just substitute the values and we can have our answer. Let us learn how to convert grams to moles and liters to mole. How these conversions are achieved. The formula will be same, but its understanding is very important. So you just need to remember N is equals to m upon gmm. Suppose you have been provided with the number of moles and we want to calculate the mass. So we can have our gram atomic mass or gram molecular mass, and then direct we can calculate mass. Let us see another question. Calculate the number of atoms of the constituent elements present in 53 grams of sodium carbonate. So what actually we want to find out is number of atoms of sodium, carbon and oxygen present in Na2CO3. So what we will do is, we'll first find out number of moles, then number of molecules, and after that number of atoms. So here the given mass is 53 grams, and on calculation the gram molecular mass will be 106 grams. So if the formula N is equals to m upon gmm, that is equals to 53 upon 106. When we solve it, our answer comes to 0.5 moles. Now we know that 1 mole equals to 6.022 into 10 raised to power 23 molecules. So 0.5 will be equals to 3.011 into 10 raised to power 23 molecules. Now let us see the next step. In one molecule of Na2CO3 there are 2 sodium atoms, 1 carbon atom and 3 oxygen atoms. So if we are having 3.011 into 10 raised to power 23 molecules, that will contain 2 into 3.011 into 10 raised to power 23 sodium atoms. Similarly, one sodium carbonate atom contains one carbon. So 3.011 into 10 raised to power 23 molecules will be containing 3.011 into 10 raised to power 23 carbon atoms. And similarly, we can calculate oxygen and the answer will be 9.033 into 10 raised to power 23 oxygen atoms. So in this way, we can utilize the concept of mole and calculate gram atomic mass, gram molecular mass, and molar masses of different substances. So that's all with respect to mole concept. To excel on this part, please try to learn some atomic weights as well as molecular masses of compounds which we come across daily. For this, you can refer your NCERT textbooks. So that's all. Thank you everyone. Stay safe, stay healthy.